All right, everybody, thank you for coming to my talk here at 11. Prioritization myths busted with better vulnerability data. I have a lot to say, so I want to make sure I get started and make good use of my time here. The very first thing I want to do is say a couple things about me. So I have a background in physics, math, statistics. I got my bachelor's in astronomy, but I'm currently a data scientist at Flashpoint. We collect a lot of really great vulnerability and threat data, and then turn that into actionable intelligence that our clients can use to improve their cybersecurity programs, make better risk decisions, and so on. In particular, I've been able to help the kind of full pipeline of data stuff, from data collection, research, problem solving, implementing, creating new risk models and scores, just trying to tackle absolutely anything that I can. So that journey has kind of shown me and taught me a lot of things, and then hopefully we're going to talk about them here. So that's a little bit about me, but I want to ask a couple questions about you guys. How many of you prioritize cybersecurity tasks as part of your job function? Okay, a couple liars in the audience. How many of you work with vulnerabilities in some form? Okay, a lot of you, that's good. And then lastly, how many of you is this their first time at RVAsec? Okay, good amount too. All right, well, that's great. Like I said, we have a lot to cover, so I definitely want to stay on task. But you know what, I'm hungry. It's only a little after 11, so for those of you who have never been to RVAsec, we're going to have lunch after this. Lunch is provided. But when this talk is over, I was thinking of going somewhere for lunch. And there's a lot of options in Richmond, and only so much time. So it looks like I'm going to have to prioritize where I go to lunch. So I was thinking I would go everywhere for lunch. But then I realized that probably would take a lot of time. I can't really eat a lot, so I probably would only really fit one meal in me, so that's not going to be practical. I thought a little harder about it, and I thought maybe I would go to Arkansas for lunch. But then it would probably be like dinner time by the time I got there. It wouldn't really satisfy the assignment, right? But you know what's right around the corner is this nice French restaurant, and I was going to maybe get the $40 steak frite for lunch. Well, that seems a little rich for my blood. And what it looks like I'm going to have to do is maybe prioritize a little better where I go and spend my time. So what is prioritization? Prioritization is a process by which one sorts and filters options according to some goal or constraint. Now, you might think I pulled that definition off of Google. I actually pulled that off the top of my head, and I'm very proud of it. Now, what do we mean by a goal or a constraint? A goal would be like, I want to go find a cheap meal for lunch. A constraint would be my limited food budget. Sometimes they're kind of two sides of the same coin. A goal is minimizing something, or a constraint is the thing you're minimizing. So that's sort of the goal of prioritization in general. Examples of things you might have as a goal or a constraint are money, time, opportunity. There could be opportunity costs of something you're doing. And then when we say sorting and filtering, what we're talking about is putting options in some kind of order, like my favorite to my least favorite thing or something like that. And filtering might just outright disqualify some options entirely. So that's sorting them right to the bottom so that I never have to look at them ever again, right? How I do this sorting and filtering is by what I'm going to call metadata. This is additional information about my options that help me filter it. And as far as restaurants go, we're all familiar with this thing, right? Like you go on Google and you search for restaurants. And you can say, I want something more pricey, less pricey, something nearby me. Obviously, it has to be open, right? If the restaurant isn't open, that basically just filters it right out from my options. So here's a question, given all this information I just spat at you. Who here has prioritized today? Should be everyone, right? There were 3 talks running at 11. You came to this one. I assume for some reason you didn't just roll a die or something like that. We're prioritizing things all the time because there's just so much going on. We have to prioritize if we're going to tackle it all. Now we're going to come back to this kind of restaurant analogy. We're going to solve that problem eventually. But one of the ways in which we're going to talk about prioritization is the prioritization of vulnerabilities, right? And I'm going to share with you some things that you already know, maybe some things that you don't already know. One of the big ones is that ransomware is a huge, huge problem. It's hugely costly, something you want to avoid. We all know that. Not all ransomware is caused by a vulnerability, but some are. Here's something that maybe you didn't know. We've been tracking data on the time between vulnerabilities being disclosed and an exploit coming out. And you can see here from this handy chart, since 2017, that time has been decreasing pretty steeply. So whereas it maybe took 4.5 days for an exploit to come out after disclosure of the vulnerability, it's now become a little more than 3.5 days. So we've lost a day. So this problem is not getting better. The pressure we have to remediate things is getting heavier. And the data that you need to make those key prioritization decisions is also failing. So those of you in the vulnerability world, if you haven't been paying attention to some of the problems with NVD lately, they basically just stopped tagging vulnerabilities. And what that means is they've stopped delivering for you the metadata on those vulnerabilities that you will need to sort and filter them, and therefore prioritize. And that's a huge problem. So we have this goal that you want to patch your vulns, and then we have a constraint, which is you have limited amount of time and people and resources and reputation that can go and all of that stuff, right? So we got to do something, but how, right? And that's where the prioritization comes in. So we can prioritize using metadata we can collect on vulnerabilities. And what does that mean exactly? Well, there are a couple things you might want to know about a vulnerability. Obviously, I'm not going to list them all here. But one would be, is it easily exploitable? Can I very simply take advantage of it? Another one might be wondering what kind of technologies it affects. Could be a nasty vulnerability in a piece of software or hardware that I don't own, which would basically filter it out of me even thinking about it, because it doesn't affect me. I might wonder if it's actually been used or being used actively in exploitation. That's also really important. And I also might be curious about what kind of attention is on the vulnerability. It might be really scary, but literally nobody knows about it, so it's not that big of a deal, versus something everyone's talking about. That's also really important. So these are the kinds of things you might think about when you're thinking which vulnerabilities you should tackle first in this situation. So we're going to make a really big assumption during the course of this thinking, which is that you know what all your vulnerabilities are, and that you have all the metadata you would ever want to make a decision, which is a huge assumption. If you're curious how I arrive at that assumption, come find me after this talk. I simply don't have time during it. And given that, we're going to think, what do I do with that information? So I have everything in front of me. What do I actually do? So you need a plan, right? Some kind of plan. Well, here's an idea, right? When it comes to lunch or going to a restaurant, everyone has different opinions. I'm not really a food snob, so I care more about is it easy to get in and get out? Is it cheap? Some people care about the quality of the food. For vulnerabilities, there's really one thing, and it's avoiding exploitation, right? If you can do that, that's golden. Sometimes that happens directly or indirectly, right? You might have that goal because you're directly trying to avoid exploitation. You might patch a vulnerability because you are required by mandate or some kind of regulatory requirement to do so. But that requirement exists because they want you to avoid exploitation, right? So all roads lead to this one point. And that makes prioritization actually a lot easier because you can weigh those things we talked about against how well they avoid this exploitation question. So here is an example of a, thank you. Here's an example of a prioritization plan that we can have, right? We're going to find out which vulnerabilities are most likely to be exploited. All right, we'll do that. Then we're going to give them a number that corresponds to that likelihood. Makes sense? We're going to fix the highest numbers first. All right? And that would be a very, very effective strategy, right? We were able to do that. Well, what does that mean, though, an effective strategy? So some of you may or may not know, I'm kind of alluding to a thing called EPSS in the vulnerability world. EPSS is the exploit prediction scoring system. It is, or it assumes to be, an estimate of the probability that a vulnerability will be exploited in the future. So EPSS is a number from 0 to 100, and if it's an 80%, then what they're saying is, hey, this vulnerability has an 80% chance of being exploited in the future. That's what EPSS is. Very straightforward. Does exactly what we just described. And I was reading the 2023 EPSS paper. They put out an academic paper that describes it, and there were a couple things that stuck out to me, a couple statistics that I thought were interesting. One of them was that organizations fix about 15% of their vulnerabilities. So as much as you want to fix as many as possible, you're going to hit about 15%. This is one thing they claim. Another thing they claim is that only about 5% of vulnerabilities are actually actively exploited. So what that means is you're going to end up chewing through a lot of vulnerabilities you didn't have to fix. And that happens because you don't actually know which ones you should fix. And that's because you don't have a great prioritization plan. So that's the aim of EPSS, is to kind of fix the math on that. And I have a graphic that'll really show you this, and hopefully the colors show up nicely on the projector. So this circle would represent all your vulns, right? This little, I promise you it's red, circle, would represent the vulnerabilities that you actually need to go fix, right? It's actually a very small bit. And your goal is to take this blue circle and cover that red circle. So you can think about it like, you're going to shoot a missile, right? That's your remediation. And the blast radius of that missile is this blue circle, and your target is the red circle. So the prioritization plan is something that would be like your targeting system for your missile. It's something that would make sure that that blue circle covers the red circle, right? So there are a few strategies we can take here. The first is to just nuke the entire problem and fix everything, right? That would definitely cover the red circle. It would be impossible for anyone to do, but it would have what's called perfect coverage. You would definitely cover the issues that are important. It would have horrible efficiency, be terribly inefficient, and it would be a lot of effort, more effort than you can spare. The other thing you could do is just do nothing, which would be perfectly efficient if you're worried about efficiency. Would require no effort on your end, but then you just wouldn't be doing your job, and we shouldn't even be talking if you're going to be doing that. So obviously, the best thing to do is to fix just mostly the right things, right? That would be the baby bear in the Goldilocks scenario here. And I'll kind of cut to the chase and just show you what the EPSS paper found. I just mocked up a more visual rather than number-based kind of analysis of what they find in the paper. And you can see, for example, if you fix all of the remote code execution vulns, that blue circle does a pretty good job of eclipsing the red circle. It's decent. EPSS v1, the first iteration of EPSS, eclipses it about the same amount. So as technological and futuristic as the first EPSS was, it was pretty much just as good as fixing all your RCs, truth be told. Another thing I'll point out is just that when you look from EPSS v1 to v2 to the current v3, the blue eclipses the red more and more and more because it is getting better and better and better at recommending those vulnerabilities that you really actually do need to take care of. And that's great, right? That seems pretty effective. So we did it. We made an effective prioritization plan. We're probably maybe only 10 or 15 minutes into this, so I'm glad that we took care of it so quickly, because as we all know, effectiveness is everything. But wait, it isn't, right? So here's examples of metadata we collected on two vulnerabilities, two Oracle WebLogic vulnerabilities. And you see there's just kind of a buffet of information here. We have CVSS scores, a social risk score, which estimates like how much people are talking about vulnerabilities, whether it's remotely exploitable, a bunch of stuff. Can you spot the difference between them? They're pretty identical, except for maybe one thing. You don't have to actually say it. I'll say it. The EPSS v3 is wildly different. And do you know why that is? Hopefully no one says yes. I don't know. I don't think anybody knows. And that's because EPSS v3 is this gradient boosted, black box, opaque, machine learned thing. And it spits out numbers that it says is correct. And by all means, it seems correct. But you can't actually audit it or figure out why it's working. And I'm going to make maybe a bold assertion, which is that effectiveness is really important. But you know what else is important is is the score flexible? Is it intuitive to understand? Is it accessible to us? Is it transparent? So EPSS is not very transparent, right? You can look on their website to say what goes into the model, but literally how the neural network is producing things, no one can explain it. It's kind of by design unexplainable. And then accessibility is obviously important. EPSS doesn't have this problem, but if I had the perfect score but refused to give it to you, that would kind of be an issue. And then intuitiveness, right? I don't know about you guys, but I'm super curious. So when people make recommendations, I'm always like, why? Why is this working? Why isn't it working? Stuff like that. And so I think that all of those things are really, really important. So all right, given that, what about something that is like totally flexible and totally transparent and all of that stuff? Well, that would be more like CVSS, right? This is a severity score on a vulnerability between 0 and 10, and it's more or less just designed with like flowcharts like this one, where you answer the questions and it tells you yes, no, maybe, and then you feed those yes, no, maybes into what's called a vector here, and then the rubric just says beep, 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 beep. Well, this adds up to a 10.0, right? And then you fix the 10.0s. That seems really straightforward and great, right? And here's a plot of how those scores actually end up, just based on the factors that they look for in CVSS, in this case V3. You can see there's like a lot of highs and mediums maybe, not a lot of lows. That's just the way it is, but that's great. You know, we know how it works, we know what goes into it, we can just go and fix the highest number first, right? But then we have another problem. We said we can fix about 15% of holes, but the highest number in CVSS is 15% of holes. So what you've just done is successfully separated the 15% you're gonna fix from the rest, but now where do you start with the 15%? You kind of just hit a dead end, because basically all of the ones you carved off are the highest. So CVSS alone is really not a good prioritization plan or vector to just run with. So here's just my little restaurant analogy. It would be like if I had a questionnaire for restaurants and I asked things like, is the food good? Are the meals cheap? Is it nearby? Is the service quick? There would only ever be 16 possible scores at the end of it, right? Because each of these is just 4 yes/no questions. And what that means is if there are 1,000 restaurants in Richmond, something like that, more than one will get a perfect score, and then I'll be sitting there going, well, I have 5 options that are all great. Which do I pick still? And that would give me analysis paralysis even still. So this is not good enough. I would not know which one I would go to. And the issue is that we've ultimately just bit off a little bit more than we can chew, and we still haven't answered the question, right? We sort of made ourselves that sandwich, but we can't quite bite into it yet. So all right, maybe what we need is some kind of consensus. So we have a lot of scores and prioritization methods that are complex and effective. This is good. We want things to be complex enough to be effective, but we also like the elegance and transparency of something that you can explain in retrospect. And so what we would really want is something that everything can agree on, right? The scores that are complex agree and the scores that are simple agree. Here's an example. Here's an issue where the CVSS is high, our social risk is high, location is remote, which is kind of the highest vector there. The EPSS is actually quite high. 53.17%, by the way, is really high for an EPSS V3 score. That's a different conversation. I'd be happy to tell you about it if you're curious. So this seems great. It seems like we just do that. We just look at it, and if it's all red, we celebrate and we do it, right? And ultimately, that's because we probably should agree on everything. Well, not all the time, right? So here's what I'm going to call Ben's 3 laws of consensus. The first law is, if you ask 5 people for an opinion and they all agree, that's really great, right? You're like, where should I go for dinner? They all say this place, and you go, wow, that comes very highly recommended. I'm going to go there. Ben's second law of consensus is that if you ask those same 5 people for another opinion and they all agree still, that's a little suspicious, okay? And Ben's third law of consensus is that if you ask them for a third opinion and they still all agree, run. That is bizarre. No one agrees that much about anything, literally anything, okay? I'm making this bold claim here, and I dare you to prove me wrong. And that's because of systematic bias. That's how this comes about, right? This definition I did pull off of Google, don't want to take credit. The inherent tendency of a process to support particular outcomes is systematic bias, and it's because of dependence. You have things that end up depending on each other. So for example, your friend tells you to go to a restaurant. You look it up on Yelp, and it has a high rating. You say, wow, my friend must really know what they're talking about. You ask them for another recommendation. The first one was so great. They look at Yelp for high ratings in your area. And then they tell you about another restaurant. This is a problem, right? Your friend doesn't necessarily know anything. They don't even have to be dishonest to do this, right? Maybe they just think you don't know what Yelp is, right? So this is something that we always need to be aware of when we get a lot of opinions that end up collating with each other. This seems like an aside, but I'll wrap around to this point. There's a thing called the KEV, the Known Exploited Vulnerabilities Catalog. It's something that CISA runs, and it lists, like the FBI's top 10 most wanted, it lists vulnerabilities that they know are being exploited. They know these are being exploited. So if you're going to take care of anything, you should take care of these things. And this is just a chart of what they've added in the last couple months, or since the beginning, every month. And you can see that in the beginning, they backfilled a bunch of vulnerabilities. That's why some of those bars are really high. And ultimately, this is what it's like on the KEV. There's a lot of vulns exploited in the wild. The KEV never even purports to be a complete list of those things. So the things on the KEV are more like this red circle, right? There's a lot of overlap. One thing you'll notice is that the red circle actually overhangs the yellow a little bit. And that's because there are vulns on the KEV, or at least there were vulns on the KEV, that aren't actually being exploited. Now, how can I claim this? Well, there's a really great blog post that explains that because of some misunderstanding by Palo Alto, CISA ran with it, added it to the KEV, and we were off to the races at that point. So when we look back at this vulnerability, which is the vulnerability I'm talking about here, the reason that EPSS is high is because it was on the KEV. And then the reason that the social risk score is high is because everyone was talking about it, because, hey, it has a high EPSS and it's on the KEV, and all these things. And so you get this runaway effect where things really feed into each other. And this is just a snapshot of what it looked like at the time. Now the KEV has pulled the vulnerability and all these things, and you know what happened? Everything went down. And it's because these things are interdependent on each other, and it's sometimes a good thing, but not always a good thing. So all right, let's go back to the basics. Let's think about what it is we know and what it is we don't know. And just as a bit of a mea culpa, there are a lot of things that I've been complaining about, and I want to admit to them. I've complained about having too much stuff to do. I've complained about not being effective enough, complained about things being too complicated. I've complained about things being too simple. And I've also somehow managed to complain about other people agreeing too much. So what can we say we know for sure? What would even I agree we definitely know? Well, let's look at this vulnerability. It seems pretty bad. You know, it's got a pretty severe, people are talking about it, remotely exploitable. That EPSS score is really paltry, though. It's so low. This maybe tells me that EPSS doesn't, you know, predict confluence stuff very well, maybe. Maybe that's why it is, or else I don't know why it would do that. And I guess that's just my assumption going into this, and maybe that was just validated by seeing how low that EPSS score was. Except maybe my assumptions shouldn't be validated. So I've complained about a lot of things, but you know what I haven't complained about yet is you and me and everyone else, because we do this thing all the time, and I drive myself crazy with it at least, where we say, I don't know what to do, so we do some research and gather data, and then we go, well, that doesn't look right, so we throw it out, and then we're back where we started. And that kind of stinks. And specifically, it's this part, right? You're going from saying, I don't know something, to, well, now I know enough to say that it doesn't look right. And those things are a bit at odds, right? That's because stuff needs to be evidence-based as much as we can help it. So my list of complaints just grows larger, and that's a little irritating. So we've looked at a lot of options. We've looked at simple options, we've looked at complex options, we've looked at, you know, a combination of both, maybe just trusting my gut, and it's a problem. And when I see all that, I wonder if maybe we shouldn't just have one standard. We all put our heads together, we create one standard that everyone can follow. Well, this is bad news. So some of you have probably seen this comic before. It says it better than I ever could. Basically, if you have a situation where there's a lot of standards and someone tries to unify them all they're doing is adding to the problem more and more. And this is, here's another bold claim I'm going to make, a good thing, I think. So when it comes to, like, they give the example of AC chargers, I get why it's a problem. You don't want to have to lug around a pile of cables that get all tangled in your backpack. When it comes to prioritization methods, there's really no reason why you can't use more than one or get kind of weird with it, right? And what I mean by that is just that a computer can comprehend one row of numbers pretty much as fast as it can comprehend 2 rows of numbers, right? And so this is where maybe technology is going to bail us out of this problem a little bit. So in summation, I really just don't want to be creating problems I can't also help solve. It's sort of a personal philosophy of mine. So I want to walk through what we've learned and then maybe pitch how we can solve that. So one thing we've learned is that a good plan would be complex enough to be useful, but simple enough to still be understandable once we implement the plan and look back on it. Another thing is that we need to be open-minded enough to accept new evidence, not just your feeling, especially when your existing evidence isn't great. But also we need to be skeptical of an overwhelming consensus. And those last two are really important to me. One of my heroes is Carl Sagan, and he said that science was the marriage of skepticism and wonder, right? You wonder all of the ideas, and then your skepticism kicks out all the bad ones, and what you're left with are just the best ideas, right? So that's also really important. And then lastly, you really shouldn't expect things to be super simple. And I know we all want things to be simple, but the reality is that you're going to have to, roll up your sleeves and really figure some stuff out and put the work in sometimes. So given that, do you want some help building what I would say is a good prioritization plan? All right. This is what I'm calling Ben's simple 4-step proposal. Step 1, we're going to collect a bunch of metadata. That's number 1. Second thing we're going to do, we're going to rank the importance of that metadata. So we'll figure out where the restaurants are, then we're going to figure out how expensive they are, and we're going to decide which one we care about more. Then we are going to find a set of non-dominated solutions that prefers higher ranked metadata, and then we're just going to fix those first. All right? Sounds like a plan. And I'm glad that we're finally able to tackle this. We're about 26 minutes in, but we're finally answering the question that we were all wondering, where should we go for lunch? So here's a bunch of restaurants. In theory, we've got an American restaurant, we can go get Thai, we get pizza. I guess pizza doesn't really count as Italian. Whatever. So I've collected some information on how they perform in each of those 4 categories that I cared about. Italian restaurants, nice. It's a little pricey. And then what I'm going to do is I'm going to say, I care about how close it is, because I got to get back before the 1 p.m. And then I care about price. I don't want to drop too much money. It's just lunch, right? Quality, whatever. And then service, I don't care. I just want to get in, get out. I don't even want to talk to anybody. If there's a kiosk where I can put in my order, I'm happy. So this is step 2. So step 3, maybe the more complicated step. So I want to talk a little bit about a Pareto front. Now, has anyone heard of a Pareto front? I'm going to be so amazed if anyone raises their hand. There's a guy. Okay, so you've heard of the Pareto principle, right? Similar Pareto, or same Pareto. So Pareto front is a way of looking at features to figure out what a defensible solution would be. And what that means is, if I had 2 quantities, let's say, how close it is and, how good it is, right? That circle, and these are all restaurants plotted here, that restaurant N is categorically better than K. It is higher on both axes than K. Furthermore, E is categorically better than N. So A, B, C, D, E, F, G, H are all good options, all defensible in some way or another. All of the gray stuff is just outclassed by anything on the Pareto front, right? So this is a 2-dimensional Pareto front. If I could plot this in like 3, 4, 5, or 8 dimensions, your minds would explode. So I haven't done that. But this is how we're going to think about this problem. So looking back at our restaurants, the pizza restaurant is great. I love pizza. The location is as good or better than anything. The price is as good or better than anything. The quality is not as good as the Italian restaurant. And the service is not as good as the Mexican restaurant, for example. However, those last 2 are my least favorite things, the least important things to me. So the pizza restaurant is actually the best option. Second best, the Mexican restaurant, right? Because they have an A in the most important category, and they outclass even my pizza restaurant in a few of them as well. So given that, I can keep doing this exercise. And it's important to point out that I'm not necessarily ordering these as like 1, 2, 3, 4, 5, 6. I'm creating tiers. So when I sort this, pizza is the top tier. The Mexican and Thai restaurants are the second tier. Italian after that, and then the French and American kind of fall to the bottom. And you could really add more columns onto this to increase the resolution of the prioritization plan in order to really sort things out. And then there's a lot of conversations we can also have about what if I like the first thing more than the second, then I do the second thing more than the third, right? This is in math non-Euclidean is what we call it. But you can see how this would really help us at least start tackling the problem. I mean, I've narrowed it down. I'm going to go get pizza, right? So here's an example, just from a vulnerability example to take it back to the less interesting problem, from May 16th. And what I've done here is I've just listed some vulnerabilities that I thought were interesting. I've also collected some of my favorite pieces of metadata on those vulnerabilities. For example, the CVSS v3 score, the 2 EPSS scores, and the social risk score. And just looking at that, I can order it just like I ordered all my restaurants, right? And this is great. Just as a little bit of justification, and because we have time, I'll explain. As much as I kind of maybe crapped on EPSS v3 a little bit, I actually like it quite a lot. Our social risk score, I'm also very proud of, and I'm happy to use. It's also interesting that only one of the vulnerabilities kind of broke through and is still socially relevant. Now, EPSS v1 kind of falls in the back, but there's a reason why I included it at all. It might be weird to you that if there was a v3, anyone would ever use the v1, right? And the answer is the v1 is transparent. It's not as effective as v3, but you can see why it's working. Obviously not from here, but if you ask me, I can tell you why. Because they make it clear how and what goes into EPSS v1 to have it generate numbers. Another thing I'll point out is why do I consider a 1.3% EPSS v3 interesting? So if you read the EPSS paper, going back to some of the numbers we talked about, they recommend they assume you're going to fix about 15% of vulnerabilities. If you start at the top of EPSS v3 and work your way down until you hit 15%, you'll actually get down to EPSS about 2.2%. And that's where EPSS is also a little bit unintuitive. You would think this thing only has a 2% chance of being exploited and I should fix it. It's a little weird, but that's just the way the numbers shake out, and they didn't fudge it any bit to make it more intuitive. Which is kind of a good thing, but it also makes it a little bit less practical. So given that, this is how I have more or less ordered them. I push CVSS v3 to the back. CVSS v3 very much overly over-represents severity. Everything gets skewed up in CVSS v3. So I found it interesting that we had a 3.3, but otherwise these were all pretty samey as far as that. So that's more or less how I arrived at this conclusion. This is all programmatic. If you have this information, you can go home and you can go do this exact exercise. And then you will have completed my 4-step proposal for prioritization. Now, this is a bit of a Frankenstein, just like that guy. Well, Frankenstein's monster, forgive me. And there are a couple benefits to doing this. First of all, it utilizes both complex and transparent scoring systems. So we have some of that consensus. We have some of that agreement. But it's not fully reliant on everything agreeing. Another thing it does is it is itself a complex system, but is based on actual logic. So if you understood what the hell I was talking about with the Pareto front thing, you'll understand that it's like logical, right? But it is also complex in that I had to take a couple steps. It's not just a number that I spat out. It also understands that people will have different preferences. So you might say, well, I care more about the restaurant's location than the price or something like that. Then that's up to you. My exercise did not rely on me ordering those columns in that order. That's just how I felt, right? So if you had different priorities, you can prioritize what you prioritize, right? And then lastly, it's based on real information that you gathered, right? It's not just based on the vibe. There is evidence there, and if anyone ever asks you, well, why did you prioritize this thing, you can say, well, look at the scores. As an organization, we really care about these factors, or we pay a vendor a lot of money to recommend these things. So they said this, and that was important, and they're high in both of those categories. So we're not throwing out EPSS. we're just taking it with a grain of salt a little bit and saying, well, that alone wouldn't drive these decisions, something else might. And given that, it seems like I succeeded. And I imagine that now everyone will agree with me. So I want to take questions. Question?
Hey, thank you for the talk. It seems like if you are in the practice of actually remediating vulnerabilities on your own attack surface, there's another dimension, which is not just how severe is it, but how many of it do I have? Because you might have a medium severity confluence vulnerability, but you got 200 of those servers. So I guess the first question is, have you experimented with like factoring in the number of vulnerable systems? And then the other question is, a lot of the time we use CPE data to associate a vulnerability with an asset that you own. But CPE data is kind of flaky and not maintained super well. So I'd love to hear you comment on.
Oh, absolutely. I will take any opportunity I have to trash on CPE. CPE is a mess, right? It's horrible. There are, I don't know, 100 million GitHub repos, something like that. Are they going to make a CPE for all of them? Does anyone know the answer to that? No, right? It's crazy. And if you look at how they even handle things like OpenSSL, how they create the vendor and product URIs is totally inconsistent. It's a mess. I heard at some point, not firsthand, but I heard that CPE was going away, but I never heard any kind of 2.4 that's coming out. I never heard what it was going to be replaced with. And I'm kind of amazed that everyone still talks about CPE, right? Part of me is like, I don't want to think more about CPE because it's just going to go away, but then suddenly not suddenly, but it just doesn't go away. It's so like stubbornly stuck with people. It stinks. It's horrible. I don't like it, right? Not to mention the official CPE dictionary is owned by NVD, so anything NVD fails at, CPE is going to fail at. It's a horrible mess. I could go on and on. But your point about number, right, quantity, well, that is just another piece of metadata that's maybe not metadata on the vulnerability itself, it's on the vulnerability in context of your environment. So if you say, well, this is really bad and it only affects one system, this is kind of bad, but it affects 10 systems, then that weighs into your risk calculus, right? And that's all important. I didn't really talk about that just because I think it gets a little complex. Another thing to keep in mind that makes that a really good point is also you might run Apache 1.0, which has 10 vulns, and you go, oh, well, that's a lot of vulns. I'm going to patch up. Apache 2.0 has 50 vulns. That's a problem too, right? So sometimes you go into exactly how am I going to remediate and what are the costs of doing that, right? And the cost-benefit equation might change based on that. Okay. Satisfied? Yeah. Okay. Any other questions? Yeah.
I just want to throw out, thank you for the talk. I want to throw out a plug because I had to build a vulnerability management program for my organization, and I used the Scientia Institute's Prioritization to Prediction series, and it is very, very much in alignment with what you just explained and has been super eye-opening and has really been able to guide us into how we're going to solve this problem. So if anyone is looking for like a piece of paper that explains some of the stuff in more detail, again, very much in alignment with what you just said. So check that out.
Yeah, that is, the Science Institute is behind EPSS, or at least was. I think formally first.org is, but it's a lot of the same people as far as I'm aware. And yeah, that series is really great. And it's, as a data scientist, I'm a little bit of a black sheep sometimes because I'm sometimes a data science doubter or a hater or whatever the cool kids call it nowadays. In that I really, really, really care about understanding why we are doing things. So if I said, prioritize this vuln, and that is the correct answer, let's just say we know it's the correct answer, you're gonna ask me why. I just know you will. And that's why I think it's so important to understand why, and why we need to be careful not putting all our eggs in one very opaque basket. Okay, another question? Thought I saw one. Yeah.
Has your proposal been operational successfully in a large organization?
Whether they know it or not, yes. Just because I've worked with clients who ask me, because we deliver this data, I'm not allowed to shill too much, but we deliver all this data, the stuff that I showed you, we have it. And so when clients are trying to implement it, they say, it's like, they have the buffet in front of them. Like, what do I do? And I recommend something like this, yeah. Get all of the data, just like I quoted Carl Sagan earlier. You get all the data, and you say, well, these things seem interesting to me, and then you decide that. And that's something that people need to be mindful of is, this might sound insulting, you gotta care, right? Sometimes you ask a client, you tell that to a client, like, I have good news, the world is your oyster, you have all of this stuff to make decisions on, and they're still stuck. It's like, your dreams have come true, now you get to do that thing you've always wanted, and it turns out they didn't actually ever want anything. And so sometimes it's about inspiring in them, and telling stories like this and saying, well, this is what I've seen people do, and all of that. But yeah, this is very intuitive to me. And if you get to know me, you'll learn that this kind of thing is actually how I think about literally everything, including what I wore today and stuff like that. Because I'm crazy. Yeah, go ahead.
So in my field, I have another dimension to this on prioritization, and that's the political impact.
Okay.
So for us being one of the intel agencies, we do not want to be on the front of the Washington Post. Right? That's number one, which I think goes to your social media.
Yes, absolutely.
And the other reality for us is we may all agree in the SecOps team, right, that we got to do this. And then as it percolates up the chain to the CISO, the CIO, they may have a completely different reason for not doing something, right? Or doing something that we really scored low, but because of the Washington Post reality, no, you got to fix this.
Yeah.
Example for us was the Atlassian Confluence thing, which we're like, okay, but oh my gosh, we got to fix that.
Right.
So that's, at least in our field, the federal field or public sector field, that's one that we have to live with. That personally, I wish we didn't have to pay attention to that, but that's what the leadership cares about the most.
Yeah, and there's two angles to that, right? One of the angles is you want to avoid being on the front pages of the Washington Post, or you don't want Krebs talking about you or whatever, and that's important. The other one of just I have to listen to my bosses no matter what they say, that just makes me glad I studied math and not business administration or anything like that. But yeah, the Washington Post thing is really important, and that's why I glossed over it, but one of the early slides I mentioned reputation being a constraint or a goal when you're prioritizing is, and I don't just mean, because the way you started your question, I wasn't sure where you're going to go with it. I don't want to be on the page of the Washington Post. There's also internal politics and reputation, right? Where you say, I have enough, cred to make one weird recommendation and people will listen to me. So I have 3 weird recommendations I could make, and I'll only get away with one of them, right? This is something that I've had a lot of experience with because I think weird things sometimes. And so that's also an important thing you need to prioritize is, this is a cheap thing to do, and it would be easy for me to do, but if I bring it up to this guy, he's going to hate me. So you need to be careful of that as well. Question way in the back.
Is there any metadata for prioritization that you wish had better quality data, was easier to collect? For example, someone was talking about the number of systems that were affected, but maybe someday the value of systems that are affected would be useful for prioritization, but might be hard to quantify or collect data on that.
Yeah, great question. There's probably too many. I think, so it all comes down to asset stuff, right? Knowing your assets is not the topic of this talk, and I'm grateful for that. And it's what the gentleman said about CPE as well, right? That's sort of the biggest dragon to slay, and it sort of falls into my wheelhouse because it has a lot to do with implementation and also data science. So you might have a Windows 10 system, but what is that? Is that Windows _10? Is it Windows :10? Is it W10? Is it W space 10? Is it Win 10? Right? Everyone calls it different. And if you and I are talking, I can just say Windows, and you'll assume I'm running 10 or 11 or whatever. But a computer needs it very literally, right? So if anything, I wish that were more consistent. I wish there was kind of a Tower of Babel that we created so that we could all speak the same language on assets. Obviously, I'd like to tackle the greater know your assets problem, but that greater problem will not be solved until we create that Tower of Babel where we're all talking about the same thing. That's probably what I'd say. Yeah?
That graph you showed about CVSS was really enlightening, and I'm wondering whether, I'm not sure whether this is too niche of the
That's a good question. So I'm not an expert on CVSS as far as the components. I just sort of look at the end result of it all, right? And I guess I would, it stinks, but I would just add more vectors probably. For CVSS, that's what they did between V2 and V3, among other things, right? I think the V2 vectors, I forget how many there are, let's say 6, and I think there's maybe 8 or 9 on V3. And if you added even more, that would adding more always increases the resolution of things, generally speaking, right? Just as if they cut some out, it would decrease the resolution of things, which would be bad. So that's maybe one, but also you got to be careful because, like I said, if you look at the distribution for V2, it's actually a little bit more normal. And if you look at V3, they skew all high and critical. Is there a question back there? Are you scratching your head? Yeah.
I really like to talk about it. Thank you. I'm wondering how you rationalize, I think many of us have to deal with this, the best practice standards and guidelines are just scan your stuff and fix all of it, right? And so then we write policies where we aspire to essentially do that. And then we have the reality that you talked about, which is we do it like some of the time, but honestly not that often, like 15% of the time. How do you rationalize those three things within the model that you just proposed? Because I really love how like real this is, but then I've got these two other factors that my customers are like, we expect you to fix everything within like 3 days.
Yeah, that's a good question. It's funny, sometimes a client, sometimes you give the client the speech and you wince because you're like waiting for them to fight you, and then they don't, and you're like, oh, that was nice. And then sometimes, they do fight you, right? Again, I went into math and not psychology. Maybe there's something there that's important. What I'll say is that another maybe controversial statement is that the whole system where we're scanning every now and then and all that stuff, that sucks. We got to stop doing that, right? That's part of it. And then the client would probably ask, well, then what do I do instead? And that gets to knowing your assets and all of this stuff, right? So I'm afraid that change will maybe be a little arduous, is sort of the answer to that. But hopefully this is like a dangling carrot to say, look how nice things can be if you need that. And if anyone wants to talk to me more about like what we do to try to solve that problem, just find me. I look like this. And I can talk about it. Yeah.
Echo, great conversation, great presentation. I'm curious though, how many SOCs or security teams are actually leveraging data scientists?
Oh, that's a good question. I guess I don't know. I mean, I know how many leverage me. So, I would probably put the number at, leverage me to some extent, I don't know, 50 or more, right? But how many have a data scientist? Look, let me, in my limited time here, let me rant a little bit about data science. So I'm studying data science in graduate school, and they teach a number of things. One of them is Gen AI, LLMs, neural networks, and stuff. That seems to be about 90% of what people say or mean when they say data science. Whether you realize it or not, you just watched a presentation on what's called operations research, which is under my umbrella of data science. I'd consider it data science. Broadly speaking, but it does not overlap with the popular conception of data science. So you could be asking me how many teams have operations researchers. The answer is probably all of them, right? We're all operations researchers for some portion of the day. And then a special shout out to dynamical systems, which is my favorite part of data science that nobody talks about. All right, you guys want to go to lunch?